Hello.
Welcome to week four of the workshop, and I'm sure many of you must have attended the first 3 weeks, and I'm sure you've gained a lot from them. So this week is going to be centered around data science, career insights, and industry practices, and it's going to be hosted by myself. So my name is Oriolorun Oluipinlayi, and I am a machine learning engineer working for a company called Crowdhelix. And just before we begin, just a general announcement from the organizers. So there's going to be an airtime giveaway for the three most active attendees. So I just thought I should let you guys know. So, and on that note, we can begin. So yeah, I've broken today's session into four parts. So the first is going to be career paths. So in that section, I'm going to tell you about the possible career paths you can take if you decide to undertake if you decide to build a career in data science. The second would be resume tips. Just, tips and tricks on what worked for me personally when I was building a resume as a beginner. So I'm assuming a lot of us here are, people that are transitioning to the tech field from other fields. So I've kind of structured this presentation to cater to those particular kinds of people. But if you're already in the data science path already, and maybe you're looking to switch jobs or you're looking to like get your first job, this would also be beneficial to you. The third section will be centered around interview tips. Just, tips on, again, what worked for me when I was looking for a job as a newbie myself. And then the fourth section is a day in the life of a machine learning engineer. Because for me, within data science, machine learning is my own area of specialty, and that is what I will be speaking on. So, moving on. So, in this workshop, I'm sure there's a section on data analysis, and yeah, but I would not be doing data science justice without talking about data analysis as a career path. So, yeah, what is data analysis? Data analysis is basically the process of inspecting, cleaning, transforming, and analyzing data to discover useful insights, inform conclusions, and support decision making. So yeah, imagine companies generate a lot of data. So data analysis is basically just that field, and data analysts are, those people who make sense of this data being generated by the companies. So an example scenario could be a case where a retail company wants to understand which product categories performed best in the last quarter to optimize inventory and marketing strategies. So in that case, obviously that kind of company would have, data on, their sales data, how each product performed, and how each product category performs. So as a data analyst, you will be the one to go to the database or the data warehouse to get data pertinent to, this particular scenario and analyze it to inform decision making. Tell them, oh, these are, the products that performed well. This is the product category that we should focus on going forward. So key responsibilities in, this field involve collecting and cleaning data. Obviously, like if we're going to analyze data, we need to like fetch them from some kind of data store, and we need to clean them because they might not be in a shape to analyze. We might need to remove missing values. We might need to remove duplicates and the likes like that. So that would be the first thing we do. The second is we perform statistical analysis. So your mean, median, mode, of course, that's a very simplistic view towards data analysis. But yeah, you would do things like that. That's where, statistics comes into play. And you're doing all of this so that you can identify trends and patterns. So if you identify trends and patterns by analyzing the data, then you'll be able to inform relevant stakeholders on, what the data actually mean. And then they create visualizations and reports. Yes, after analyzing data, it's easier and easy to digest when it's, in visual form in terms of, graphs and, charts that would make understanding that data at a glance easy. And of course, would want to create a comprehensive report so that whoever is making, a decision based on that data actually understands what the data means. And of course, communicating findings to stakeholders is also very important. So that's where your communication skills comes in, because you would have to report and explain the analysis that you've done, what, the results mean, and what possible actions we can take from the results themselves. And on the tooling part, here are some common tools that data analysts use. This is not exhaustive. And again, it's not exactly my field. So anything I'm saying here is basically like general knowledge. But yes, Excel, a very important tool that data analysts use. Some may argue that if, the data set is very large or, the data store is very large, that Excel might not be able to do the job, but yeah, it still is a tool that's like widely used among data analysts. And also the SQL, yeah, it's going to be the most common kind of database that you would find. So it's just a place where data is stored. So you have to learn the language to, query a database so that you get relevant data concerning whatever, task or scenario that you have to analyze. And then there's some visualization tools like Tableau, Power BI, Looker Studio. These are just like, business intelligence tools that, help you visualize data at a glance. You can also build automated pipelines with these tools so that once, fresh data is going into the data warehouse or data store, the visualizations get updated. And lastly, you have Python, general purpose when it comes to, data science related fields, and, very useful, powerful libraries like Pandas, NumPy for analysis and visualization of data. You have Matplotlib and Seaborn. So yeah, that's a general overview of data analysis. So just to cap that up, data analysts, what they do is, they make sense of data basically, in a nutshell. So we can move on to data engineering. I don't know if there's a section on data engineering in this workshop. If there is, again, I would still need to mention them here because it's a very important, career path in data science. So what do data engineers do? Basically, data engineers, they focus on building data pipelines mainly. So they're building pipelines to store and to make sure that data is stored in an efficient manner. And yeah, they're building pipelines, also thinking about, efficiency of processing and retrieval as well, because once those pipelines are built, they're thinking about how easy would it be for data that is stored to be retrieved for use cases, down the road. So a possible scenario for a data engineer could be, say, a fintech company needs to process and store daily transaction logs for fraud detection. So depending on where the transaction logs are created, they need to be moved from that particular point in the software ecosystem to a kind of data store. So it could be a data warehouse. Mostly going to be a data warehouse, to be honest, because that's where you can store a bunch of unstructured data. So they would build, the software pipeline that would get those fraud those transaction logs from where they are generated down to the data warehouse where they will be stored and processed and retrieved by whoever wants to use those logs for fraud detection case, which could be a data scientist or a machine learning engineer down the line. So key responsibilities, just like I said, so they develop and maintain ETL pipelines. So yeah, ETL basically means extract, transform, and load pipelines. So this is the process of you fetching data from its point of origin. You extract, that's the extraction phase. You transform that data into some kind of useful form that you want to use for your use case. And then you load, that data into, the data store that you want it to be in. So which is the loading phase. So that's called an ETL pipeline. So secondly, they design and manage databases and data warehouses. Again, yes, it's one of the things that you do. This again is not my field, but this is something that data engineers do. Concerning tooling, so obviously it's a data related field, so SQL very important as well. So because they need to be able to, query these databases if the need arises. Then there's Spark, there's Kafka, Hadoop, Snowflake, BigQuery, Airflow, and of course Python itself. Because this is a data related field, and that is Python is the language of choice basically. So that's a brief overview of what, data engineers do. So in a nutshell, data engineers help you move your data around, basically. They build pipelines to make sure that data is moved from one place to another efficiently. And thirdly, we have data science, which is the name of the field itself. But yeah, it's also like a particular set of predefined rules or tasks that you need to perform within a job. So it is um, a job field itself. So who is a data scientist? So I like to think about a data scientist as someone who combines the role of a data analyst and a machine learning engineer in a way. And that being said, in many places, it depends on the job role, to be honest, because some jobs would say data science and, most of the roles will be machine learning related. Some would say, you know, data science and you'd mainly be, expected to do data analysis tasks. But yeah, in the actual sense of it, I feel like in the actual sense of it, I feel like data science is a field that combines data analysis and machine learning engineering to a particular extent, and they rely on some domain expertise to extract meaningful insights from complex data and drive business decisions. So what is like a scenario where data science comes in? So say, for instance, a telecom company wants to predict which customers are likely to cancel their subscription. So this is your classic churn modeling problem, which is again a kind of task where you'd be required to, fetch data from a database, clean this data, analyze this data, which would be something you expect like a data analyst to do. And also you'll be expected to build a machine learning model, a churn prediction model, basically, which is something that you expect a machine learning engineer to do. So that's why I said data science is basically like a combination of data analysis and machine learning engineering. So what are the key responsibilities? So exploring and modeling data using machine learning techniques, like I said, building predictive models, very important. They build predictive models as well. So it doesn't just stop at analysis. So after analyzing the data, deriving insights from the data, then they build a model to predict some particular prediction targets that has been set up. They perform A/B testing and experimentation. Again, when you're testing your models, experimentation phase, and they communicate results through reports and dashboards. Kind of something that you expect like a data analyst to do. But in actual sense, for every field in data science, I feel like communication is very important. Communication and documentation because you will do a lot of presentation. So, and concerning the tools that they use, Python, very important. Libraries like NumPy, Pandas, Matplotlib, Seaborn, and the likes. SQL, very important to know how to, get data when you are assigned a particular task at work. Jupyter Notebooks, very good tool for experimentation. I'm sure we're all familiar with that. And cloud platforms to a particular extent, because if they are using, say, Colab for experimentation instead of Jupyter Notebooks, or if that particular data science role requires you to deploy models to production, then you would need to be very conversant with your cloud platforms as well. So yeah, in a nutshell, what a data scientist does is they basically perform analysis on data and build predictive models, predictive machine learning models. So I'm moving on to my personal favorite, which is my own part, machine learning engineering. So yeah. So what does a machine learning engineer do? So a machine learning engineer focuses on designing, deploying, and maintaining scalable machine learning models in production environments. So that is specifically what machine learning is all about. So what we do as machine learning engineers is we build uh, machine learning models basically, and then we deploy them to production. So you might wonder, so how does this differ from data science? Well, in actual sense, it differs mainly because of, the software engineering burden that you are expected to shoulder as a machine learning engineer. I like to say machine learning engineer as, a data professional who is like a cross between a software developer and a data scientist. Of course, they are not as skilled as, your typical software engineers, but, you're expected to do a lot of software related things in combination with you, building machine learning models. So I feel like that is the big difference between the two. Another difference could be the kind of models that you're expected to build. While a data scientist might be expected to focus more on, the statistical models like, linear regressions, SVMs, my machine learning engineer might be expected to focus a little bit more on things like recommender systems, things like large language models, computer vision models, yeah, and NLP models and the likes. So what is a possible job scenario for a machine learning engineer? You could have an e-commerce company who wants to show personalized product recommendations. So this is your classic recommender system. So what is a recommender system? Basically, you want to you have in e-commerce, you have like a lot of products on the website. So you want to be able to narrow it down for one particular user. You want to be able to suggest to them products that they are likely to be interested in so that you can drive sales, basically. So recommendation system is it's a very big staple in the machine learning field. Key responsibilities, training and optimizing machine learning models. That's a staple. Deploying models to production. Again, it depends on the size of your team, and it depends on, the requirements of that particular role. You could have a bunch of MLOps engineers waiting on you to finish training your model and then they do deployment. But what I find is in most cases, companies expect you to be able to not only train your model, but actually put those models in production by yourself. They prefer for, machine learning or data science teams to be self-contained in the sense that while there are professionals in the team that can build models, they also expect someone within the team to have the skills of deploying models to production. So again, it depends on the size of your team. You might not have that skill, but most likely there will be someone else in the team that has that skill. So you'll be required to deploy models to production. You'll be required to, monitor these models in production for performance and, retrain if needed. So if performance in production begins to degrade, you would be required to retrain this model. This is not typically a manual task. It's something that's automated. So you would set up an automated pipeline that, once performance drops below a certain threshold, it triggers a model retraining job. And once that is trained and fine-tuned, then it's deployed and replaced. Tools. So yeah, there are lots of tools that machine learning engineers use. Machine learning engineers use like, Python, obviously TensorFlow, PyTorch for your more deep learning use cases. Scikit-learn from the more statistical side of, machine learning models. Docker, Kubernetes for deployments. MLflow for ML ops, like retraining jobs and the likes. Flask and Fast API would be used for writing API endpoints to, transfer data between your model and whatever service is consuming that model itself. Linux, not really necessary, but I feel like it's very important because if you're dealing with, cloud infrastructure like virtual machines or you're collaborating using Git, although there is you a UI that you can use for Git, but it's really handy to be able to do that on the CLI. The CI/CD, because again, if you're deploying, you don't want to be doing that manually. You want it to be an automated pipeline, and that's the CD. For the CI would be for collaboration sake. So you want to be able to run automated tests as you're collaborating on a particular repository and your cloud platforms. Very important if you're deploying models into production, because you have to know the difference between serverless deployments. You have to know what an API gateway is. So all of those are things that you interact with, and there will be, services provided by one of the cloud platforms, basically. So yeah. And then we can move on to AI engineering. So AI engineering and machine learning engineering are kind of very similar. But and AI engineering is I would say relatively new, because it's a new job title that's coming up these days. And I would define it as basically a machine learning engineer that deals with AI models and AI systems. What do I mean by AI models? Um, so an AI model would be something like, say, a large language model, like ChatGPT. So companies have use cases where they expect you to use these large language models for whatever feature that they're trying to build. So the feature would be driven by that large language model. So they prefer to refer to professionals who build the software around either a self-hosted language model or one of, the APIs like the OpenAI API or, the Gemini API. We prefer to refer to those professionals as AI engineers. But in many places, or in many teams, I can see, Olakunle, I can see your question, and I'll make sure to attend to it either now or at the end of the class when we have the 20 minutes section for questions and answers. Thank you. So yeah, in many places, a machine learning engineer would still be required to do all of these things. But just for the sake of being thorough, I've included it in this particular slide. And what is a possible scenario for an AI engineer? Say a bank wants an AI chatbot to handle customer queries. So either they're self-hosting or they're relying on some kind of API. As an AI engineer, you'd be required to build the API around whatever wherever you are hosting the large language model that would allow it to answer questions based on the context of the bank. So either you're building a RAG system or you're building, some kind of agentic workflow, you would be required to do just that. So key responsibilities, designing AI-driven applications. Yes. So if, your company has a feature or a particular product that they want to put out that would rely on an AI model, say an LLM, for instance. So you would be required to do that. You'd be required to integrate AI models with software applications. Say your company has a particular product, a legacy product that they feel would benefit by integrating, say, ChatGPT, for instance, in the back end or on the user-facing side, you will be required to do that. Optimizing AI performance for scalability and efficiency, developing agentic workflows, like I said. So tools, again, the obvious Python, Docker, AI APIs, Hugging Face transformers for your NLP models, CI/CD, and cloud platforms. So, moving on to resume tips. So, just a disclaimer here. I will be saying everything I'll be saying here will be based on my own experience. These are things that worked for me during my own journey. So yeah, I really don't know what the market is like these days, but these are the things I found helpful when I was looking for my first job as well. Um Olakune, so you said, what do AI engineers need Python for? So as an AI engineer, you are still building software. So at the end of the day, you're writing an API, you'd probably be writing it in Python itself. So you still need to understand how to use the Python programming language. So resume tips, a minimalist design. So just something plain. I honestly, in my opinion, I think something like this works very fine. Uh, it's easier for the ATS systems to parse, and if it's going to be reviewed by the recruiter, then it's easier for them to be able to get what they actually need from, you know, the CV at a glance. Showcase personal projects, deployed if possible. So again, I'm assuming a lot of us here are looking to transition into the field. And yes, there's a lot of advice to work on personal projects, and that is, very valid advice. So if you have your personal projects and if they are deployed, then they should be located in the experience section. Although you don't have real work experience, but working on personal projects shows that you're a self-starter. Include a link to your GitHub account. Again, this is, you trying to demonstrate that you can actually work in a technical role, that you know a programming language and you can actually put products out there. A one-page CV. So again, this is just to make it easier for the recruiters to, you know, pick relevant information from your CV. So it's basically just to ensure that your CV is not bloated, really. Skill section just under professional summary. So yeah, as a junior person, it's advisable to have your skill section under your professional summary so that again, making it easy for the recruiters to get what they need to get from your CV at a glance. So being conscious of time, although this the presentation might run into the other 20 minutes, but we'll have like 7 minutes left here. So just being conscious of time. I would like to speed this up a little bit. So interview preps and tips. So be honest about knowledge gaps. It's very important to be honest about what you don't and do not know, because they can actually. I know we're all asking questions now. I can see your questions. Um, so I'm not ignoring these questions. I'm just being conscious of time. Please, can you note down these questions? Because at the end, there will be time for me to answer these questions. Thank you. So yeah, be honest about knowledge gaps. So it's very important for you to be honest during your interview about, things that you know and things that you do not know, because that would help set expectations accordingly concerning, say, the next stage of the interview or concerning, how you are onboarded if you do get the job. So if you do not have relevant experience, lean on personal projects. Say you're in a situational interview session and you are asked a question, a technical question. You do not have relevant experience in the field, in data science field, but you've worked on personal projects. So it's a good practice to, speak based on the personal projects that you worked on. How did you solve this problem? How did you solve that problem? So that would demonstrate that even though you do not have, experience at the moment, you actually have some experience working on something data science related. Demonstrate the passion for the field. Do you write? Do you, contribute to open source? That would, be a very, very big plus in a very, very big plus for you in an interview scenario. Because I remember for the job I'm working on right now, I remember during my interview, one of the interviewers was actually looking at one of the articles that I'd written because I do some technical writing. So it was one of the things that really impressed him during the interview itself. So yeah, ask questions at the end of the interview. I know this is something that has been said a lot of times, often overflogged, but yeah, it's important for you to ask questions at the end of the interviews because it shows that you are invested in the process as well. And yeah, show your communication skills. Very important to show your communication skills because if you're going to be working in the data field, communication is a very, 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 very big factor because there won't be many people within the company that actually understand what you do. So it's on you, it's your duty to be able to explain to them what you built, how you built it, and how it benefits the system, how it benefits, the company itself. So showing your communication skills is very important in an interview because they're going to expect you to come in as someone who would be able to communicate with stakeholders concerning features and, the work that you do as a data scientist. So, yeah, a day in my life as a machine learning engineer. So, a typical day is mostly made up of, these four things, meetings, model training and experimentation, coding, and then documentation. So days when I do model training and experimentation, there isn't much coding. Typically, when model training and experimentation is done, then I can switch to, the more dev side of things, like, writing an API and putting together a repository for the project itself. And of course, very important again is documentation. Like I said, many people might in the company would not really, I mean, they would appreciate your work, but they might not know, the intricacies of what you do. So it's important for you to document. It's also good for, team dynamics. So if there's a new member of the team, or if someone needs to get up to speed with your project, since they'll be joining you on the project, they would be able to just go to the documentation and read up on, the work that you've done, things like software architecture, system design, model choice, things that you've tried during experimentation that worked and did not work. So that's very important as well. And as a bonus, I would be making a small case study on a project that I worked on at work. So basically, it was a use case where we needed to host a large language model for our own use case. We needed to host it locally for, data privacy and security reasons, and also for, ease of should I say updating the model as we please. So we had that concern, so we decided that we needed to self-host our own language model instead of using one of the APIs that are present. And in my company, I'm the only machine learning engineer on the team, so I actually work end to end from the ideation phase all the way down to product delivery. So phase one of the project had this objective, which is deploy and manage a large language model on our own servers. So I'm going to take you through the phases involved in doing something like this. Again, this is from my own point of view, based on my own role and in the company that I work with. So the first thing is a stakeholder meeting. So yeah, this is where the use case is discussed of the businesses. Oh, the stakeholders, they say, oh, we have this problem and that problem. how can it be solved? So this is where you have preliminary discussions on if and how machine learning can help solve this particular problem. And the key process here is communication. So it's basically just a brainstorming session between the stakeholders and yourself. So if it is a use case where machine learning can solve the problem, then you can go into that and then you can then proceed and build a model or do whatever you need to do. So actually, we have less than a minute left. So I am going to stop the meeting here, but please rejoin the meeting again using the same link so that we can, finish the rest of the presentation. Thank you for your patience. And then you'll be able to ask all of the questions that you need to ask as well.